come. The video is posted. But I do have just a couple more free response examples I want to go through. So we did the sneezing problem the other day. That was an example of regression. So you need to know how to do that on your calculator. All right, then we've got this question. A ball is thrown off the roof and its height at time t is given by this equation. Okay? So the height at time t is given by this equation. This equation gives us the height. So the questions are, what's the height after 2 seconds? What is the maximum height? And when do you reach it? And when does it hit the ground? Okay. So, how do we do this? Well, the first one's easy. The equation gives us the height at time t. So if we want the height at time 2, we'll just plug in 2. So h of 2 is negative 16 times 4 plus 200 plus 14. This is a calculator problem, so we would have a calculator, but let's see if I can do this without. What would that be? 200 and, oh no, 100 and what? 150? Alright, so that's 150 feet up. Alright, what is the maximum height and when do we reach it? Now, this is a calculator problem. So could we graph that equation on our calculator and use the maximum button, second calc max, to find the maximum? We absolutely could. And when we do that, see, this is a parabola opening down. When we do that, when we find that maximum, it's going to be 2 points, right? Or two numbers, I mean, 2 coordinates. So one of them will be the maximum height, and the other one will be when we reach it. Which one is which here? When I type this into my calculator and I do second calc to get these points right here, what's what? What's going on here? What's this one? That's x, which in our problem is t, so that's the time. So this is when it reaches the maximum height. And then that's y, which in our problem is h, so that is the actual height. Now, could that problem be done without a calculator? Yes, because what do we call this point right here? The vertex. And how do we find the vertex of a parabola? Negative b over 2a. Negative b over 2a. Now that question, find the vertex of the parabola, is a no calculator question on the exam. You have to know negative b over 2a. You could use that here, if you wanted to find the maximum. Since that's just a parabola, you could do that. All right, when does it hit the ground? How do I do that one? What? I want the zeros of the equation. If it's on the ground, then the equation is set equal to 0. So, I'm going to solve this equation. Now, if I already have the equation graphed from problem B, could I use that graph to answer this one? Yes, only I wouldn't be looking for the maximum, I would be looking for the zeros. Because, okay, if I graph this thing on my calculator, it's going to look like this, and that would be the point I was looking for, right? So second calc and then choose the 0 option instead of the maximum option. Okay, so let's get the answers to that and we'll be all set. Move on to the next problem. So get rid of all the old stuff. Put these in. The maximum is 3.125 and 170.25. So when it says find the maximum height, the answer would be 170.25 feet. And when it says when does it reach the maximum height, you would say after 3.125 seconds. All right, now when does it hit the ground? I'm going to use the same picture. Use the same picture. And now I'm looking for the 0 though. And I got, for the 0, I got 6.387. Which means, when does it hit the ground? If I'm right, if I didn't make any mistakes, after 6.387 seconds. Could this be done without a calculator? That's just a quadratic equation. You're going to have to solve one on the exam. How do we solve a quadratic equation? With these numbers, I would probably use the quadratic formula. Now, you do want to be careful. If you did that by hand, you'd get 2 answers, and one of them would be extraneous because it would be a negative, so you'd want to throw that one out if you did it by hand. It wasn't an issue on my calculator, but you do it by hand. All right, what else do I have? Okay, the infamous box problem. These are all examples of free response questions. So I've got a box, and let's say it's 12, or I got a piece of paper, I'm sorry, I have a piece of paper that's 12 by 30, and I'm going to make a box the way we do it, you know, cutting out the corners, folding up the flaps, same way we've always made the box. And I want to find the maximum, what are the questions? I want to find the maximum volume. I want to find the equation of the volume. I want to find the domain. And I want to find when the volume is at least, I don't know. I'll say at least 100. We'll see what happens. Okay, so here we go. These questions are not in any particular order, by the way, because we probably want to do this one first, right? So what's the equation for the volume of this box if the paper is 12 by 30?
12 minus 2.
3 things, length times width times height. So it would be 12 minus 2x, 30 minus 2x, and x. There's your volume. That's the equation of your volume. Your domain, that's your x min and max, is 0 to 6. So I'm going to go ahead and put in that equation. I'm working on this now. I've got this graph. I want my maximum volume. So I have my calculator set up 0 to 6, and I use 0 to 500. And I see what I need to see. See my nice little parabola. So my maximum is 2.64, comma 438.55. Did I do that right? Okay, so now be careful, because the question could be asked, lots of different questions could be asked. This one said, what's the maximum volume? So the answer would be 438.55 cubic inches, right? But we could also say, what are the dimensions of the box with the maximum volume? So if that were the question, then these are the dimensions, right? Length, width, height. So whatever your x value was, you have to put it in here. So the length would be 12 minus 2 times 2.64. And the width would be 30 minus 2 times 2.64. And then the height is 2.64. Those would be the dimensions of the box. All right, now we want the volume to be at least 100. So what do I do if I want to know where is the volume at least 100? I'm going to put in another line. I'm going to graph the line where y is 100. And I'm going to get a picture that looks like this. And this is where the volume is exactly 100, right? So I'm going to find those 2 points. And how do I find those points? Intersect. And it looks like it's about 0.3 actually. That one's 0.3. Then I have to repeat for the other one. Anybody else get 0.3?
Yeah.
Like 5.5 is the other one. Okay, now 0.3 and 5.5 are the places where what happens? The volume is exactly 100. We need the volume to be at least 100. So that is everything in between them. Right? Because in between there, the volume is more than 100, right? The volume is higher than 100. So at least 100 would be 0.3 to 5.5. What would less than 100 be? Less than 100 would be from 0 to 0.3 and from 5.5 to 6. That would be less than 100. This is all more than 100. Okay, one more. I have a set of parametric equations. And I want to find the points where t is 1, 2, and -3. And then I want to find the direct algebraic relationship between x and y. And we noticed the other day, or yesterday, that question is asked on the review sheet, write the Cartesian equation. Anytime you're talking about x and y, you're talking about the Cartesian coordinate plane, x and y. So that means the same thing. Find the direct algebraic relationship between x and y means write the Cartesian equation and sketch it. Okay, so find the points. That's easy. If t is 1, what's our point? What's our x and y if t is 1? 6 and negative 1. What if x is 2? 7 and negative 4. And if x is negative 3? 2 and negative 9. There we go. So those are the points where t is those things. Could we find more points if we needed them? Yep, we can find as many points as we wanted. Now, find the direct algebraic relationship between x and y. That means instead of 2 equations, have 1 and no t's. So what could I do to have 1 equation and no t's? We get t by itself, so t is x minus 5, and then plug it in right here. So y equals negative x minus 5 squared, or negative x squared plus 10x minus 25 if I FOIL it out and distribute the negative. Now what's that look like when I sketch it? Well, let's look at it here. I think it's easier to see here what it looks like. It's an x squared, so it's a parabola. It's got a negative in front of it, so it opens down, and it's got an x minus 5 inside the parentheses, so it is shifted to the right 5. So it's a parabola that looks like this, and that's the 0.5 comma 0. So there's your sketch. Okay. All right, that's all I had. So what do you have for me? What kind of problem do you need to... I am not interested in wasting your time. If we have no other problems to talk about, you can use this time to study. If there's any problems we need to talk about, we're going to take care of them now. Peyton.
Can we do one where you have to change the sign on y, change the sign on x, or like
find the symmetries.
Yeah.
So we want to tell, here's an equation, let's say x squared equals y plus 5, and we want to know what symmetry this equation has. And the symmetries are the x-axis, the y-axis. The symmetries we check for are the x-axis, y-axis, origin, and identity. Okay, to test for symmetry about the x-axis, we change the sign on y and say to ourselves, are these two the same equation? And the answer is no, they're not. To test for symmetry about the x-axis, we change the the y-axis, we change the sign on x. So we ask ourselves, are these two the same equation? And the answer is yes, they are. Because when you square negative x, you get x squared. So those are the same equation. So we do have symmetry about the y-axis. To test for symmetry about the origin, we change the sign on both. Oops. And when I simplify that, I see that it is not the same as the original. So it does not have that symmetry. And to test for symmetry about the identity line, I switch my variables. Clearly that is not the same equation. So, the only symmetry this one has is the y-axis. It is definitely possible that something will have no symmetries. Most things in the world have no symmetries. None of these anyway, okay? So none of these is a definite possibility for a question like that. Okay, what else? What else?
You know when we like the translations, you have to say if it's decreasing or...
I don't know what you're talking about. Say it again.
You know when you have the translation graphs, you have to say where it's decreasing or where it's increasing?
Like on the additional overview,
Yeah.
number 7.
Like this.
Right here.
Yeah.
I don't know when it tells.
You don't know what goes up and what goes down?
Well, I do, but I just don't know how to do it.
Silly girl. All right, let's take a look at this picture. I'll just randomly draw some picture. I gotta put marks in here now. Okay. All right, so I want to know the intervals on which it's increasing and the intervals on which it is decreasing. Increasing means it's going up. So Taylor, from here to here, my pencil goes up, right? That's from -3 to -2. My pencil is going up in that little space. Where else is it going up? It's going up from here to here, which is from 0 to 1. That is not hard. It is that easy. Where's your pencil going up? We're talking about moving left to right, so we're looking at x values. What x values is my pencil going up for? What x values is my pencil going down for? So where am I decreasing? I'm decreasing from here to here. So from -2 to 0, I am decreasing. And where else am I decreasing? From here to here, which is 3, 4, 5, 6, from 3 to 6, I am decreasing. Moving left to right, x values, going up, going down. Olivia? No, I'm not doing any problems from the review sheet, but tell me what kind of problem, I already did those, but tell me what kind of problem it is and I will do one like it.
Well, I'm not really sure what kind of problem.
Okay, what does it say?
It says, 5f(x) - 2
So if I have a function like 3x squared plus 9 and I want to find f of 2x plus 1. Anytime I evaluate a function, that just means I pull out the x's and plug in whatever they tell me to plug in. So if it said find f of 8, I would plug in 8. Well, this says plug in plug in 2x plus 1. So f of 2x plus 1 would be 3 times 2x plus 1 squared plus 9. Just take out the x and plug in whatever they tell you to plug in. That's all there is to it. Then we FOIL out, distribute it, and all that stuff. And we don't do anything with the answer. We just leave it alone. So 12x squared plus 12x plus 12, I guess, would be the final answer after I distribute it, if I added right. There is nothing you can do to that. Nothing. If you did anything to that, it would be wrong. There's nothing to do to that. It's not an equation, so you can't divide by 12. You could factor out a 12, but that is the opposite of simplification, so we wouldn't want to do that. All right, what else?
Could you give an example of a problem with a slant asymptote?
Yep, it's the only way an equation is going to have a slant asymptote is if the power on the top is bigger. So the way the problem is worded on the exam is it says find all the asymptotes. So if we had an equation like this, and it said find all the asymptotes, we have a vertical asymptote at x equals 3 because vertical asymptotes happen when the denominator is 0. Because the powers don't match and the power on top is bigger, we're not going to have a horizontal asymptote. Our slant asymptote is found by literally doing the division. This is a division problem. It's a quotient, it's a division, do the division. So when I do the division, I come up with 2x plus 11. The remainder is irrelevant when I'm doing a slant asymptote. So the slant asymptote would be y equals 2x plus 11. It's what you get when you literally do the division indicated in the problem.
That's only when the power on top is bigger than the power
Yep.
on the bottom.
If the power on the bottom's bigger, where's your asymptote? No. If the power on the bottom's bigger, your asymptote's at y equals 0.
Are you dividing by
I'm dividing here. I'm doing this division problem. I'm doing the problem, the actual division in the problem. Which I did synthetically. You can do a long division if you wanted, but I don't know why you would do that, but you could. All right, what else? What else?
There's one like number 24. It says find the function. A function is defined parametrically by x equals t squared minus 1 y equals
Okay,
2.
now I already did one of those today. You know that, right?
Yeah.
Okay. But you want me to do another one?
Yes.
Okay, so x equals 2t and y equals 5 minus t. All right, so what do you want to know? What's the equation? What's the Cartesian equation?
Find pt.
Cartesian.
Yeah.
The Cartesian equation is the algebraic representation of x and y in a single equation. That means just get rid of the t's. So if I just get rid of the t's, let's see. Oh, I could do it up here. I guess it really doesn't matter. So x over 2 is t. So y equals 5 minus x over 2. Another way of writing that would be 1/2 x. So negative 1/2 x plus 5. Now, you don't have to do, this is good enough. This is good enough. I did this because if it says sketch, if you look at it like this, you know exactly what that looks like, right? That's a line, intercept 5 and slope of negative 1/2. So if you have to sketch that one, you can. I don't care which way you write it. I mean, the equation is the equation, doesn't matter. But I thought this way you could tell more what it looked like. So there you go.
I think you're gonna kill me, but can you do one of like the exact value of sine 7 pi over 5 or something?
Yeah, I can't do 7 pi over 5, but I can do 7 pi over 4.
Okay.
So 7 pi over 4, I gotta change that into degrees. So 180 divided by 4 is 45 times 7 is 315. So we've got the sine of 315, which is all the way around here in quadrant 4. What's the reference angle, this angle right here, for 315? 45. So that means we got a 1, a 1, and a root 2. And that one is negative. I want sine. Sine is opposite over hypotenuse. So negative 1 over root 2 or negative root 2 over 2.
Thank you.
All right, what else?
can you do like a problem where you can just
Will you complete the square?
Yeah, and then you can tell like what the translation of it from like x squared. Like there's no problem as well. It's just like translation. So you have to like complete square.
Okay, so there's an there's the equation of a parabola whose vertex is not at the origin, so this thing's been moved. And she wants me to complete the square to tell how it has been shifted. Okay, now first of all, let's understand you do not have to complete the square to tell how it's been shifted. if you want to know how a parabola's been shifted, we just need to know where its vertex is, don't we? And we can find the vertex without completing the square. Now I'm going to go ahead and complete the square on this, but you don't have to. If you need to know how it's been shifted, you just need to know where its new vertex is, right? And that tells you how it's been shifted. But if we're going to complete the square, got to divide everything by 2 first. You cannot complete the square if there's a coefficient in front. So we'll divide everything and move the 5 to the other side. Because I have to make room, Mr. Miller calls it making room, for a new number here that will make this a perfect square. So, how do I find the number that I add to both sides? Half of 4 is 2, squared is 4. So this parentheses, this completed square, is x plus 2 squared. And I have 1/2 y plus 9 over here. And now I'll get my y back alone. So I'll move my 9 over. And then I will times everything by 2. And when I times by 2, I multiply the parentheses by 2, but not what's in it. So it's 2x plus 2 squared minus 18. So where is my vertex now? My vertex is -2, so I've gone left 2 and down 18. So if it says describe how it's been changed, we went left 2 down 18 and made it twice as skinny. Goes up twice as fast. That's a vertical multiplier. That multiplies your vertical. So everything's going up twice as fast, so it's skinnier then. So it's twice as skinny, shifting 2 units to the left and down 18. Now, if you did -b over 2a, are you going to get exactly the same vertex? Yes, so you'll have exactly the same information if you do -b over 2a. Okay?
How do you get to linear regression on your calculator?
Second, no. Stat, calc. You go to the stat menu, calc. All right, who else?
Can you do a growth and decay problem?
Well, you can't do a growth and decay, we can do a growth or decay. So which one do you want to do?
Decay.
Decay? All right, so the decay problems that we've done have been half-life problems. So, find the half-life. For an element whose decay constant is -0.432. Alright, so here we go. We're going to find the half-life. So, first of all, this is going to be a PERT. Anything that's not money is a PERT. This isn't money, so it's going to be PERT. And we're talking about half-life, which means that however much I start with, I'm going to end up with half. So if I started with 10, I'd end up with 5. Makes absolutely no difference. Pick a number, end up with half of it. And there is my equation. So I need to solve that. Clearly this is going to be a calculator problem. What do I do first? Divide. So 0.5 equals e to the -0.432t. Notice your variable is an exponent. You can't solve it until you get it down. If it's up too high, it's got to come down. So to get it down, we will ln both sides. And we'll have our answer if we just take ln 0.5 and divide it by -0.432. So it looks like it's about 1.605 days, years, months, hours, decades, centuries, something, right? Okay, what else?
Can we do the other equation instead of third?
So a compound interest problem. So what interest rate would be necessary to grow $500 to $600 in 2 years? Let's say compounded a monthly. So what interest rate compounded monthly would grow $500 to $600 in 2 years? So that's compound interest. So 600 equals 500. I don't know the interest rate, but I know I'm compounded monthly for 2 years. So that would be my setup. Notice where the variable is. Is the variable in an exponent? No, the variable is not an exponent, so therefore we will not be using logarithms. However, we start the problem the same way. We need to divide. So 6/5 is 1 plus r over 12 to the 24th power. Now, we do need to get rid of that 24th power because we need to solve for r. So we need to get it out of that parentheses. So how do I get rid of a 24th power? I 24th root it. So 1 plus r over 12 will be the 24th root of 6/5, which is easier for Mrs. Ford to think of as the 1/24th power. You may certainly do it however you want. So I got that number calculated on my calculator. I did 6/5 raised to the 1/24th power. These parentheses are all necessary. Now, what do I need to do to get r by itself? So this number is on my calculator right now. So what do I need to do? Minus 1 and times by 12. So the question was, what is the interest rate necessary? I need about 9.15% to make that happen in 2 years.
So we could multiply by 12 and then subtract 12.
If you multiplied everything by 12, including that, yep. Okay, all right, what else? What else do we have? All right, well, then the rest of the period is yours to work on whatever you need to work on. So if it's math, fine. If it's not math, that's fine too. Nobody's